Alrighty, ladies and gentlemen. So today we're going to be working with, well, I guess for today's activity, we're going to be solving inequalities. Alright, so if y'all remember in class, to solve an inequality, there were several suggestions that I had made, or suggested, I say. One of them, so y'all can circle your variable, which y'all don't have to, but the reason that I suggested y'all do that is just to try to, because that's what we're trying to do. We're trying to isolate it. We're trying to get it by itself. So I'm going to circle it to put it kind of like in a bubble. So that's the last thing that we do or work on. All right. So here. All right. So we'll circle my variable. Okay. We need to do inverse operations to get it by itself. Inverse operations are basically how do you undo something, or what's the opposite of something? Well, the opposite of subtracting 4, or the inverse operation of subtracting 4 would be to add 4. What I do to one side, I need to do to the other side. Those cancel out. We're left with 5x being less than 35. All right, so we're not done yet. 5x, ladies and gentlemen, it means 5 times x. There wasn't a division sign. There wasn't a subtraction or addition. So whenever you all see this here, it means 5 times x. But we're trying to isolate x or get it by itself. So the inverse, or the opposite of multiplying x by 5, is to divide by 5. What I do to one side, I do to both sides. Alrighty, so we're left with x being less than 7. And if we were to represent that on a number line, ladies and gentlemen, here's 10, here's negative 10. Well, here, the way you read this is x is less than 7. X is less than 7. It's not equal to, but it's less than 7. So 7 would be right here. It would be represented by a hollow circle. And numbers that are less than 7 are 5, 4, 4 and 5/10. So forth like that, ladies and gentlemen. And those are all located to the left of the number line, so that's how it would look. Alright, so on this next one here, ladies and gentlemen, it's going to be very similar to how we solved the first one here. Alright, I'm going to circle my variable. The opposite, or the inverse operation of adding 14 is to subtract 14. What I do to one side, I do to both sides. 2x is greater than negative 6. Now the opposite of multiplying x by 2 is to divide by 2. What I do to one side, I do to both sides. And we end up establishing that x is greater than negative 3, ladies and gentlemen. Alrighty, so here we have another example. The only difference is that this has a rational number here. Or I might say 1 and 5/10 x. It would be treated the same way. So here we still minus 2, minus 2. Those cancel out. 1 and 5/10 x is greater than or equal to 15. Now divide both sides by 1 and 5/10. Remember, your top number goes inside your division house. Bottom number goes outside. Before you all do anything, ladies and gentlemen, you need to make this outside number a whole number, which you do so by moving or shifting your place value or your decimal one place value to the right. What you do to the outside, you must also do to the inside. So with that being said, 15 goes into 15 one time. We have a remainder of 0. Bring down your last 0. And 15 goes into 0 times, ladies and gentlemen. Alright, so 10 is our answer. Alright, here we have another example, which you would treat the same way. The way you would read this here is x divided by 4, or x fourths, plus 8 is less than 12. So here we circle our variable. The opposite of adding 8 is to subtract 8. What I do to one side, I do to both sides. Those cancel out. X divided by 4 is less than 4. Now, what's the opposite of dividing x by 4? It's to multiply by 4. What I do to one side, I do to both sides. Those equal 1. We're left with x is less than 16. Alright, so here we have another example. However, in this case, we have a negative coefficient, or may I say, the number in front of my variable is negative. That is referred to as your coefficient. So sorry about that. Alright, so we would still treat it the same way here until we get to the end. So I'm going to circle my variable. The opposite of adding 2 is to subtract 2. What I do to one side, I do to the other side. Those cancel out. We're left with negative 5x is less than 25. Now, the opposite of multiplying x by negative 5 is to divide by negative 5. What I do to one side, I need to do the other side. However, this is the only situation, or the only time when it's different here. Whenever this number here, your coefficient, or the number in front of your variable is negative, or whenever you're multiplying or dividing by a negative, your inequality, it flips, it switches, it reverses, however you all choose to see that. So x is no longer less than, x is now greater than negative 5. Okay. Alrighty, and here we have another example, but with rational numbers this time. So there we go, I'm going to circle my variable. The opposite of adding 9 is to subtract 9. What I do to one side, I do to the other side. We're left with negative x divided by 3, or negative x thirds, is greater than or equal to 6. Now, the opposite of dividing x by negative 3 is to multiply it by negative 3. What I do to one side, I do to the other. So those cancel out. We're left with x. But if y'all notice, ladies and gentlemen, since my coefficient here, since I was dividing by a negative, my inequality is going to flip. So x is no longer greater than or equal to. X is now less than or equal to negative 18. And on a number line, ladies and gentlemen, here's 0, here's 20, here's negative 20. Negative 18 would be around there. But in this case, since x is less than or equal to negative 18, it would be represented by a solid circle, ladies and gentlemen. And all the numbers that are less than negative 18, negative 20, negative 22, negative 24, those are all located to the left of the numbers.